Well, let me first say that I think there would be no globalization without shipping. Shipping is by far the most globalized industry in the world today. Shipping is also very competitive. And I think the way we can compete and show our strengths is through quality shipping. So we have to be innovative in the way we do things.
We have to be very competitive, very productive also in a competitive environment. And I think that key is innovation.
As you know, we have about 40% of the global shipping, but we have a big increase in competition coming from the Far East. And we have to make all efforts to keep our shipping industry competitive. And in the future, I think we should keep up the innovation part very strong. Some of these challenges are around the corner.
With the price of the oil that is becoming sky high, it is extremely important for the bottom line and also, of course, for the environment because of the emission of CO2. And I think we are working very hard on this.
We have to use the intelligence that our manufacturing industry has. And I think working together on one side, the shipping companies, and on the other side, the manufacturing industry, is very important for the future.
If you have a fire starting, then the ship crew will go onto the safety center on the bridge with the captain in command to handle the emergency situation. But at the same time, they also need a lot of communication with the shore office. We transfer the real data of the situation on the ship to a computer system on shore. So they get a lot more information. And the way we have done it requires quite low bandwidth. So it's possible to do it over the low bandwidth satellite link from the ship to the shore. And despite that, have live data update as small as a 1 second lag.
Until now, if you wanted to identify an approaching vessel, you had to use a lot of different systems. Normally you have a radar system on board, but with the transponder system, it is possible to receive a ship's name, ship's position, ship's length, and all this information has been received so far on a separate system and displayed on a separate screen. So you had to combine the information in your mind, which is very time-consuming and inefficient. What we did was to combine the informations on one screen by using special algorithms, which makes it much more efficient and accurate and easier for the officer to work. Navtex integration is the integration of nautical warnings, and in the past these data have been printed out on paper, and now the information is integrated on the screen. We have also worked on a portable maneuvering display, a small handheld screen, and it shows the most important nautical information for the officer.
We get this focus on greenhouse gas emissions. If you want to reduce CO2 emissions from ships, you need measurements. The Flagship TCI is an integrated system for collecting data from several ships, identifying malfunctions or less than optimal performance in the engine. We use monthly speed trials and collect data on fuel consumption, temperatures in exhaust, and so on and so forth. And this is entered into a form and sent to shore. In some cases, we have seen bad components on an engine increasing the fuel consumption with 5%, which is a huge amount of money for the big ships. So there's really a big incentive here to take this into use.
Currently, there's no possibility for the crew to get a feeling of the energy consumption. The crew can't see into the engine room and can't see what is currently going on in the engine. So the great thing about the system is that it shows in real time the current energy consumption on board of the vessel, and just from having this we expect savings of about 2 to 3%.
The silence button is actually the first that is worn out of all the control buttons on the bridge. You look at the alarm list, but you cannot really find the cause. You cannot really see what is going on because there is so much information. So what we have developed is this alarm filtering system. You are able to silence it all in one press of a button. What is really important is that during an emergency, you need to have room for thinking, for making decisions. We use shelving of alarms that are really unnecessary. We have this screen showing you the equipment and the situation. So it's really an intelligent central alarm system. And during emergency situations, we have seen the number of alarms being reduced by more than 95%.
Essentially, it's both a set of software tools and a working process. You plan your survey, you capture the results of the survey, and you use these to intelligently refine both your maintenance strategy and your inspection strategy. You have a 3D model, and they can highlight areas which are expected to be prone to corrosion, and they can check their planned survey against class rules to see whether it conforms. The technology is designed to be used by 3 different groups of people. Firstly, by surveyors, secondly, by ship owners, and thirdly, by classification societies. But the real benefit comes from them working together and sharing information. If we can draw on this vast pool of data, we can make better predictions and we can extend the lives of ships.
During a journey, when ships move between different zones, different regulations can apply to the ship. Currently, most ships have books of regulations, and these regulations are changing all the time, and the navigator has to go through these to find out which regulations apply for that route. This is an enormous burden, and often regulations can be missed. By having the regulations in a digital form, we can dispense with these books altogether. By automatically telling the users what regulations apply to them, we make sure that no regulations are missed on the ship and that the ship's in full compliance. This stops the ships incurring any fines and improves safety at sea. We allow users to semantically search for regulations. This means that users can find the regulations they're looking for much more quickly.
Container logistics scheduling is actually a very difficult problem to solve. So we had to develop some very sophisticated algorithms to solve this problem. The main issue is speed. You've got to come up with an answer in seconds. You're looking at a movement going from the port inland, and then another customer is taking an export movement from inland back to the port. And if you can combine the two, instead of doing 2 journeys for each movement, you end up doing 1. Another problem the terminal faces is congestion. What the Flagship system does is smooth the arrival of the vehicles throughout the day, and this also makes the terminal more efficient and also a safer place to operate. The cost savings themselves, we've estimated around 10%, which in turn leads on to a very large CO2 footprint reduction.
I think the Flagship project is very helpful and it's a good project. I think it can certainly assist in consumption, measuring outlet, in operational procedures, coordinating between ship and shore, making sure that we follow rules and regulations. I highly recommend the Flagship project.
This is an excellent project where it is involved EXA, and there are also 49 organizations, European organizations, that are participating to this project. And I think it has a lot of potential.
I think the Flagship project is a good example of where we get all interested parties working together. Service providers, our shipping companies, the ports, but the industry as well. Reducing of greenhouse gas emissions is a big challenge for the shipping industry, so I think we have to get also on the innovation side, and we, from the side of the community, I think we will be ready to support such initiatives in the future as well.